We're now finally going to talk about using prime decomposition. So it says bases that are composite numbers are often best factored into primes before further calculations are undertaken. Simplify each of the following, expressing the answers in positive index form. So let's explore this by looking at our first example here. Now, the very first thing I want you to take note of is the fact that because we have different bases, I can't use my index law that tells me I can add the indices because I have different bases. But if we use prime decomposition, we can overcome this issue. So how can we do this? Well, if I've got 12, how can I break it down into its primes? Now, I don't want you to write this down because I don't expect you to do this method, but you learnt in year 7 how to decompose things. So if I've got 12, what are two numbers that I can times together to get 12? Well, that's 3 and 4. Or you could do 6 and 2, whatever you like. And then 3 is a prime, so we can't break that down any further. But 4 can be broken down into 2 and 2. Now, each of those are primes, so they can't be broken down any further. So that means that 12 is equal to 3 times 2 times 2, which means 12 is going to be equal to 3 times 2 squared. So this is the important part now, and we don't expect you to use prime factor trees, but what we expect you to be able to do is be able to look at a number like 12 and say, you know what, that is the same thing as 3 times 2 squared. And we'd be able to look at a number like 18 and break that down. Now, don't use a prime factor tree. Just think about it. 18 is the same as 9 times 2, and 9 is the same as 3 squared. So it's 3 squared times 2. And now what we can do is we can replace these composite numbers with their prime decompositions. So instead of 12, I can write 3 times 2 squared, n, times then 18 is 3 squared times 2, negative 2n. And then once I'm here, I can now just continue the question like normal. So I'll distribute out this n, 3n times 2 to the 2n times, now negative 2 times that will be 3 negative 4n times 2 to the negative 2n. Now, hopefully you can see that we've overcome our initial problem, and that is we now have the same bases. So those bases are the same and those bases are the same. That means I can use my index laws that tells me I can add them here because they're multiplying. So that means I can say we've got 3n plus negative 4n. Then times by 2n plus negative 2n. So I can add the indices because the bases are the same. Now that means I'm going to be left with 3 negative 3n. And over here, this is just going to be 2 to the 0. So this is going to be 3 negative 3n times 1, which means my answer is going to be 3 negative 3n. Now, this is where you got to be careful. Do you see how the question at the very beginning said answer in positive index form? That means I can't leave my answer like this because it has a negative index. So that means I'm going to have to take the reciprocal of it. And now that is fine. And another way you could write this is 1 on 27n. Both of those would be correct answers and acceptable. So you could either write your answer like that or like that. Okay, hopefully this was a good introduction as to how to use prime decomposition to answer questions. We're now going to go through a whole bunch of other examples, so I'll see you in those next ones.